Hi, guys. It's a pleasure to be here with you. Even though I'm not physically there, you can hear me and I can give you some examples of what we're going to do in this lesson. So we're going to begin in page number 175 in your books. And we're going to start with lesson 4.1, which is proportional relationship and slope. And the first thing we're going to learn is about slope. I mean, proportional relationships. And what is that? This is something that you have seen already in segundo de secundaria. So I hope you remember. If not, I'm going to give you examples and everything. It doesn't matter. So you can remember. All right. So two quantities are proportional if they vary and have a constant ratio or unit rate. The graph of a proportional relationship is a straight line through the origin. Relationships that have straight line graphs are called linear relationships. So proportional relationships can be represented using tables, graphs, words, or equations. And we're going to see how we can express a proportional relationship with each one of this. If you see here, we have a table. Okay, the first thing we have a table, right? This table shows a proportional relationship. How is that? Well, when we have nothing, the result of that is nothing. Let's pretend we're buying a candy. So if we don't buy any candy, we don't have to pay anything. Okay, so it's 0, 0. But when we buy one candy, we have to pay $3. If we buy another candy or two candies, we will have to pay $6. That makes sense, right? If one of them is $3, two of them should be $6. But if we go backwards, right? Let's see, if we eat one candy, it's the same thing as we have eaten $3 because that's the amount we pay for that candy. Okay, so if we wanted to make this table grow, we will do it proportionally. If we have another candy right here, like a 3, oh, I cannot write a 3. That's a 3. If each candy is $3, we will have to pay $9. And if we want to grow the table this way, and if we put a -2, we will have to lose $6 right here. If you see, we have a proportional relationship in this table because each one of them, or each unit rate, is 3. So if we go this way, we'll have to add, for every one of the items that we add, we'll have to add 3. And if we go this way, for every one item that we took away, we need to take away 3 also, right? I hope it makes sense. Now, we also can represent a proportional relationship with a graph, right? What does that mean? This same table can be graphed. Remember, X is this line right here, and Y, it's the vertical line. So this table tells me that when I am in 0, okay, I will have to pay 0. If I add 1 in X, remember, X is this way. So if I add 1 in X, I will have to add 3 in Y. Let's see the connection. I'm going to draw lines. How we know that we're going to put the dot right there. Okay, the dot will be right here. Let me see if I can draw it. Oh, something like that. Let's see how. If you see in this graph, Y, it's in the vertical zone, in this zone right here, okay? And X should be in this zone right there. So if we want to draw this line, 1, 3, or this point in the graph, in X, we will have to go in 1. So X, we move 1. And Y, we will have to move 3. So in Y, we move 1, 2, 3. So if you see, we will draw this point right here because that represents X1, Y3. Okay, this is how we graph. So good. Now, we also can represent this in an equation. Why is that? Because M is the constant. Let's see the words right here. A linear relationship is proportional when the ratio of Y to X is a constant, or M. Okay? So M, it's a constant. What is that constant? Well, that is the result of Y divided by X. If we see here, Y is, let's do the first one. 3 divided by X. X would be, when Y is 3, X will be 1. So when we divide that, we find out that M, it's equal to 3, because 3 divided by 1 is 3. Okay? So the unit rate is 3. Now we express it in the equation. The equation will be Y, it's equal to the unit rate times X. Okay, that's why we have the example Y equals 3X. What does this represent? It represents that Y, this number right here, will depend on the number that we do right here. With this equation, we're going to get this one. So it says Y, it's equal to 3 times the number of items times X. 3 times 2 is 6. So that's Y, right? If we wanted to put 3, it will be 3 times 3. It will be 9. If you wanted to know how much 4 is, so it will be 3 times 4, 12. Okay? And if we wanted to know like a big, in this table, like a big number, like, I don't know, 49. Okay, so 49, we need to multiply it by 3 to get Y. All right? So we will multiply 49 times 3, and it will give us 147. Okay? So that's why this equation is useful, because sometimes we need to give or put this table like a big number. We don't want to do them one by one, like 3, 4, 5, 6, 7, 8, 9, 10 until 49. We can use the formula to get the 49 answer. Okay. I hope you understand. You can review this video as many times as you need. All right. Let's see an example to make it a little bit more clear. Before we go there, if you go to the next page in 176, it says an equation such as Y equals 3X is called a linear equation. A linear equation, it's an equation with a graph that it's a straight line. Notice that this equation also contains more than one variable. The solution of a linear equation consists of 2 numbers, 1 for each variable. That makes the equation true. If you see this graph right here, it's a straight line. So that's why this equation, it's a linear equation, because the result when we graph it, it's a straight line. Okay, good. Now, let's learn something else. Let's learn about unit rate and slope. A rate of change, it's a rate that describes how one quantity changes in relation to another quantity. In a linear relationship, the rate of change between any 2 quantities is the same or constant. It won't change. When it's proportional or it's linear, when we add 1, we will add the same amount. So from 0 to 1, in this case, we add 2. Right? Every time we add 1, we will add 2 over here. So we add another one, we add 2 more. We add another one, we add 2 more. This number will change, right? It will be, sometimes it will be different than 2. But this one right here will always be 1. Okay? So, in this linear equation, the time to download songs is shown in the table. Okay, so if I don't download any song, I won't need any time, right? As the number of songs increases by 2, the time in minutes increases by 1. So when I don't download any songs, right here, I don't spend any time. But in 1 minute, I will download 2 songs. In 2 minutes, I will download 4 songs. And in 3 minutes, I will download 6 songs. So the rate of change, okay, it's represented by the change in songs divided by the change in minutes. In this case, every time I download 2 songs, 1 minute passes. Okay, so I divide it. The time to download songs is shown in the table. As the number of songs increases by 2, the time in minutes increases by 1. So the unit rate, it's 2 songs per minute. Okay, 2 songs per minute. That's my unit rate. How many songs can I download every minute? Well, in this example, it says 2. Good. Now, in proportional relationships, the unit rate is the slope of the line. Slope is the rate of change between any 2 points on the line. You can use the points 1, 2, and 2, 4 to find the slope. Okay, so what does this mean? The slope is like the inclination, okay, la inclinación de una línea. So how can we get it? We need to get any point in this line, okay? We'll have to get 2 points to find the difference, all right? The relationship or the change between these points. Let's take a look at this one. So the change in songs. If I download 1 song, or 2 songs, I mean, it will be 1 minute. For 4 songs, it will be 2 minutes. So my points right here are 1, 2, and 2, 4. Okay, this point right here and this point right here. Why are they expressed like this? Because the first number will always be X and the second number will always be Y. If you see this in the graph, X1, so X is right here, it's 1, and Y, it's 2. If we see the second point, this one, X is 2, and Y is 4. So we have our point right there, right? That's how we put this points like that. Good. Now, we have to find the change in those points. So we get the change in Y first. So 4 minus 2 divided by 2 minus 1. So 4 minus 2 is 2, and 2 minus 1 is 1. All right? So my change right here, let me see, was 2. Let's see example number 1. Proportional relationships and slope. The graph shows the amount of money Ava saved over several weeks. Find and interpret the slope, then find the unit rate and compare it to the slope. So the first thing we need to do is we need to find and interpret the slope. Remember, to find the slope, we need to find the change in 2 points, 2 different points. So we're going to get the point 230 and the point 115. Okay, this is y, this is x. So in the second one, or the change, it was 30 minus the first one, and the first y is 15 divided by 2 minus 1. So that means that we will have 15 over 1. Okay, this is my slope, 15 over 1, or 15. Let's find the unit rate. Remember how to do it? For unit rate, you only need one pair of points, okay? And you need to divide y by x, which is the same as the slope. So the unit rate and the slope are the same thing, okay? Let's continue with the example. And it says, to find the slope, find the constant rate of change. Choose any 2 points of the line, such as 115 and 230, then find the rate of change between the points. Okay, remember how I did it? Remember, y with y and x with x. So the y's first, the change. 30 minus 15, the change was 15. And 2 minus 1, the change was 1. So it will be $15 in 1 week. Okay, that is my slope. When we interpret this slope, we will find out that it's the same as the unit rate. Okay, the constant rate change is 15 per week. So the slope of the line is 15.1 or 15. This means that Ava saved $15 every week. In part B, it says find the unit rate and compare it to the slope. Ava saved how much per week? $15 a week, every week. So that unit rate 15 per week, which is also the slope of the line. So now we can see the connection. The slope and the unit rate are the same thing. Let's turn around. Remember that you need to do the checks by yourself. And I'm going to continue with example number 2. You can pause this video as many times as you need, review it, so you can understand it, all right? In example number 2, graph proportional relationships. The distance y in miles that a certain cyclist can ride and the time x in hours are in a proportional relationship. These can be represented by the equation y equals to 12x. Graph the equation and then find and interpret the slope. So the first thing we're going to do is we're going to graph the equation. I'm going to go here so I can graph it, okay? If you see your table, you'll find out that you have your points right there, okay? So the first point, it will be 0, 0, which will be x, 0, and 12 times 0, it's 0. Okay, this will be your y. When x is 1, y will be 12 times 1, 12. When x is 2, 12 times 2, 24. So this is what are we going to graph right here. 0, 0 will be right here. 1, we go here, 1, 12. So x is 1, y is 12. So that's my second point right there. When x is 2, y is 24. So my third point will be right there. Then I draw the line. Okay, the line should pass through every single point. So we graphed it. See, we comply with the first thing. Now, part A, it says graph the equation. Step 1 says make a table of values to find the distance for 0, 1, and 2. This is what we did right here. Okay. When 0 hours, we travel 0 miles. In 1 hour, we travel 12 miles. In 2 hours, we traveled 24 miles. Now, part B says, find and interpret the slope. Remember, the slope. How can we find the slope? The comparison or the change between 2 points. I'm going to get, oh, I did it wrong. I'm going to get these 2 points. Remember, you don't have to get 0, 0 because it won't be as good as it should be. Okay, so these 2 points right here. This point is 224, 2x, 24y, and this right here is 112. So let's see. This is y, this is x. So the y's 24 minus 12 divided by 2 minus 1, which are the x's. So 24 minus 12, it's 12, and 2 minus 1, it's 1. So my slope will be 12 over 1, or 12. In the equation of a proportional linear relationship, y equals mx, m represents the unit rate or the slope. The equation y equals 12x represents the distance in miles that the cyclist can ride in any number of hours, right? So every hour, this cyclist can go 12 miles. So to find out how many miles can he go in 40 hours, you would just have to multiply the 40 times the 12 to find out the miles right there. All right. Let's do example number 3. This is a little bit long. I hope you're understanding this. I think it's pretty easy, so you should get it right. In example number 3, it says an online music store charges $3.75 for purchasing 3 songs. Assume the cost Y in dollars is proportional to the number of songs. Graph this relationship on the coordinate plane, then find and interpret the slope. So we need to graph first. Then the step number 1 should be finding the unit rate. For every song, how much would he pay? And it says that for 3 songs, he pays $3.75. So we are going to divide the $3.75 by 3, which will give us $1.25 per song. Okay? So the unit rate right here would be $1.25, which that would be per song, right? Now, let's make a table of values to find the cost for 1, 2, 3, and 4 songs. So we already have the one for 1. We just did it here in the unit rate. And the problem gave us the one for 3 songs. So for 2 songs, what we need to do is we need to multiply our unit rate times the number of songs, okay? Following the rule here. So for 2 songs, it will be $2.50. For 4 songs, it will be $5. Okay? So this is what we're going to use to graph. Okay, we go to the next step. And we're going to graph. Okay, that's what we're going to do. So we're going to graph these points right here, which are the same that we got from the table. So in 1x, we're going to go up 125. So it will be something like here. In 2 songs, it's $2.50. Don't judge my points. They're ugly. 3 songs, it will be $3.75. Maybe something like this. And 4 songs, it's $5. Okay. So next, what we need to do is we need to connect the dots, okay, to make our linear equation as a graph. Then what we need to do is to find and interpret the slope. Remember, the slope can be found with 2 points, any of them. So you get 2 2 points from the ones that we have right here, from this, and do the change. So let's do the first two. 2.50 minus 1.25 divided by 2 minus 1. So it will be 1.25 over 1. So that's the slope. So the unit rate, it's 1.25%. What is the constant rate of change? So it will be 125. So the slope of the line is 1.25 over 1, or 1.25. This means that the cost is 125%. Okay. Why do we put this like in a lot of different ways? Because that's the methods you can use to find or solve this problem. There are several ways to do it. Okay? Good. Now, learn, compare proportional relationships. What is this? You can use tables, graphs, words, or equations to represent and compare proportional relationships. In the equation of a proportional linear relationship, y equal mx, m represents the slope or the unit rate. In the table, the slope is the constant rate of change or the unit rate. In the graph, the unit rate or slope is the constant rate of change of or the constant ratio, y over x. You can also find the unit rate from the point 1r, where r is the unit rate. Okay? Let's say it in a different way. So the cost, y, is directly proportional to the number of breakfasts. So if I go and have breakfast, I will pay $2. But if I go with my daughter, there's 2 of us, so we're going to pay $4. If I go with my daughter or my son, I will pay $6. If my husband, my daughter, and my son go, will be 4 people, so we will have to pay $8, and so on, right? So the school breakfast will go up 2 every time. The equation, so I can graph it, is y equals to x. Okay, how do we graph it? We graph this information, 0, 0 right here, 1, 2 right here, 2, 4 right here, 3, 6, 4, 8, 5, 10, and we could go on and on and on and on, right? So this is how we graph it. In example number 4, it says compare proportional relationships. The distance in miles can be covered by a rabbit in X number of hours and can be represented by the equation y equals 35x. The distance can be covered by a grizzly bear is shown in the graph. Which animal is faster? Explain. So, how can we know this? Okay, I will let you think a little bit. You should pause this video and try to solve it by yourself. That would be great. I will give you time. Now, how would I solve it? The step 1 says right here in the example in your book, find the speed of the rabbit first. The speed is the unit rate. In the equation y equals 35x, the slope or the unit rate is a coefficient of x, the number that doesn't change in the equation. Okay, in this case is 35 miles per hour. Okay, that's the first thing we need to know. Now, find the speed of the grizzly bear. The second thing we need to do is to find the speed of the grizzly bear. In the graph, slope or unit rate is the constant rate of change, the constant ratio, y over x, or the point 1r. So I'm going to go back to see the graph. So when it's 1, how much does he travel? So he travels 30 miles in 1 hour. And if you remember, the rabbit traveled 35 miles in 1 hour. So which animal is faster? With this information, we already know, or we can know, that the rabbit is faster than the grizzly bear by 5 miles per hour. Okay, let's continue the exercise, because in your book you have extra information. Okay. So it says, the method 1, find the constant rate of change. It says choose any 2 points on the line, such as 130 and 260, and then find the rate of change between the points. So 60 minus 30 will be 30, and 2 minus 1 will be 2. That's the first method. The second method, go ahead and read with me in your book. We're on page number 184. Use the constant ratio. Write the ratio, distance over time, in simplest forms for several points on the line, such as 130 and 260. Distance and time, 30 over 1 and 60 over 2 is the same as 30 over 1, which will give you the same answer. Method number 3, which is the one I used, is use the point 1r. On the graph, the y-coordinate is 30 when x is 1. So the point 130 represents the unit rate, which is 30 miles per hour. So using any of these methods, the grizzly bear travels 30 miles per hour. So when we compare the unit rates in step 3, the rate for the rabbit is greater than the rate for the grizzly bear. Since 35 is bigger than 30, the rabbit is a faster animal. Okay, I hope you followed me in this one. Right, very good. So I'm going to leave it to here. We still have one more example. Let's do it. Let me just put it right here. So here in example number 5, we can see it says the cost Y for computer repairs at Computer Access for X hours is shown in the table. Macro repair charges $23.50 per hour for computer repairs. Assume that the cost is proportional to the number of hours. Which company has a lower repair cost? And it says to explain. So the first thing we need to do is we need to find how much they cost per hour. Okay, so we already know the macro repair charges $23.50 per hour. Let's find out how much does this company charges. So it says for 2 hours in Computer Access, it costs $50. So what we need to do is we only have to find the unit rate, right? So if it's 50 in 2 hours, we have to make a division to find out that per hour, it charges $25. Okay, so with that information, we already know which one is lower, right? Macro repair will be lower because the unit cost for Computer Access is 25, right? So that's how we do it. This is simple, right? We just find out that this, well, you can do every single part of it, but we can know easily which one is it's the lowest or the lower cost for repair. All right. Now, just to finish this lesson, we're going to finish with an application right here. Isabella, it's comparing rates for 2 natural gas companies. For company A, the cost Y for X cubic feet of natural gas is shown in the table. For company B, we don't have the table, but it tells us that we can find out with the equation Y equals 0.53x, where X represents the number of cubic feet. Okay, which company charges less for 125 cubic feet of natural gas, and how much less? Okay, so I'm going to explain. I'm not going to do it, but I'm going to explain it so you can do it. Okay, you need to find first how much it is for cubic feet, and then multiply it by the 125 cubic feet that it needs. Do it with company A using this information, and for company B using this information. I want to know how you did, and we'll see you next class. All right? Have a wonderful day. Bye-bye.